How do we find the percent composition of each individual element here in calcium hydrogen sulfite? Well, first thing is we got to calculate the total mass of the compound. So let's set it up. Bam. So the first thing I'm going to do is write down the elements in the compound. So we have calcium, we have hydrogen, we have sulfur, and we have oxygen. Next is to write then the number of atoms of each. So for calcium, the subscript there is a 1. That means we have 1 calcium atom. For hydrogen now, the subscript is a 1, but hydrogen is part of the hydrogen sulfite polyatomic anion, and you have 2 of them. So if in each one of these polyatomic anions there's 1 hydrogen, but then you have 2 polyatomic ions, right? That would mean that there are 2 hydrogen. In other words, you take the subscript of hydrogen and simply multiply it by then that subscript on the outer side. All right. So same thing for sulfur. Sulfur is a 1, but then we have 2 of those polyatomics, so we'd have 2 sulfurs in total. We're multiplying, and then 3 oxygen in here, but then you got to take the 3 and multiply it by the 2, so that's 6 oxygen. Then what we're going to do is we're going to multiply those number of atoms of each by the mass of each particular element. Where do we find the masses of elements? You got it, periodic table. So let's take a look. Here is calcium, that's the mass. Now that mass could be represented as gram per mole or AMU, depending upon if you're calculating molar mass or molecular mass. So we have this 40.08 for calcium, 1.01 for hydrogen, 16 for oxygen, and 32.07 for sulfur. So let's write it down, right? Calcium was 40.08, hydrogen was 1.01, sulfur was now 32, right? 32.07, and then oxygen here was going to be 16. All right, and then to find now the total mass of the element in the compound, we're simply going to then multiply now this row together. So 40.08 times 1 is obviously 40.08, right? 1.01 times 2 is going to be 2.02, right? 2 times then the mass of sulfur here, 32.07, is going to work out to be 64.14. And then you got 6 oxygens, so just take that and multiply by the mass of each oxygen. So that's going to be 96 in total. Okay, you can add in the zeros there if you want. It really doesn't make a difference, obviously. And then to find now the total mass of the entire compound, all we're simply going to do is add this column up. So when we add that column together, we get a total mass of roughly 202.24. So now we just finished our first step. We found the total mass of the entire compound. Now we can find the percent composition or mass percent of each particular element. All right, so what I'm going to do is I'm going to add a column to this table to help us out. Bam. So to find the mass percent now of calcium, we're going to take the total mass of that calcium, 40.08, and then we're going to divide it by the total mass of the entire compound. Hence why we had to do find the molar mass or the atomic mass first, right? So this is 202.24, and then you're going to multiply that value by 100. This is a simple percent formula, part over whole times 100. So when you now plug that on into the calculator if you need to, or you can do it in your head, right, whichever one you want, the percent works out to be about 19.82, 19.82%. Let me make that 8 a little neater. 19.82%. So that is now the percent composition of calcium. So what would we now do for hydrogen? Well, we would take the total mass of hydrogen, 2.02, divide it then by the mass of the entire compound, or 202.24. You don't really need to worry about the units here, and the reason why is because the units are going to cancel no matter what. Whatever the units on the top should be the same as the bottom, so the units are going to cancel. Don't worry about if it's a gram per mole AMU. Who cares? They're going to cancel. All right, so all we're going to do is we're just going to put in the magnitudes of the number. Anyway, getting back to the point, this works out to be about 0.99%, or if we consider the rounding, it would probably be about 1.00. All right, so that's very close to 1% there. Same thing for sulfur now. We're going to take the 64.14, divide it then by the total mass of 202.24, multiply that by 100, and it's going to work out to be a percentage of about 31.71%. All right, and then last but not least, I think you get the gist, right? For oxygen, you're going to take the 96. See how nice and easy this is, though? Right, when you have a nice structure to it, it makes it so simple. And then we're going to do that division there, so this should work out to be 47.47%. All right, and what should happen here if you write everything down? Don't make a silly mistake. These percentages should add up to what? That's right, it should add up to 100. Guys, thanks very much for tuning in. I really do appreciate it. I do hope this helped. Please help us out by subscribing and liking, even telling some of your classmates. We've got thousands of videos out there just for you. Take care.